The next person I'm going to introduce is the moderator, Alden Ochoa, who really needs no introduction since she's already been partially introduced. My name is Norbert Dietrich with the Welch Foundation. Dr. Alden Ochoa is the 11th director of NASA's Johnson Space Center, better known as JSC. She is JSC's first Hispanic director and its second female director. Dr. Ochoa became the first Hispanic woman to go in space when she served a 9-day mission aboard Space Shuttle Discovery in 1993. She has flown in space 4 times, logging nearly 1,000 hours. Prior to her astronaut career, Dr. Ochoa was the research engineer and inventor with 3 patents for optical systems. She is honored to have 6 schools named after her. Dr. Ochoa earned a bachelor's degree in physics from San Diego State University and a master's degree and doctorate in electrical engineering from Stanford University. Dr. Ochoa?
Well, thank you. Welcome to the human spaceflight session, where we're going to hear about specific engineering, science, and medical activities that are taking place aboard the International Space Station, which we'll just abbreviate as ISS, so we can all say that from now on, and the challenges ahead for future exploration. So I'll introduce each speaker as they come up. And our first speaker is Kirk Shireman. He is the program manager of the International Space Station at NASA. He's been at NASA over 30 years, with more than 20 of those years in the ISS program. He's held a variety of positions, rising to the top leadership position of program manager in 2015, after serving a couple of years as my deputy in the center director office. He's responsible for the overall management, development, integration, and operation of the $3 billion per year, 15-nation program, including policy development, international partner negotiations, and the overall safety and health of the crew and on-orbit vehicle. Kirk.
Thank you, Ellen. What Ellen really said is, I can't hold the job. So it's a pleasure to be here with you this morning. Chancellor Sharp kind of hit the nail on the head. You know, I realized when Ellen asked me to come be part of this panel that I was the only one on the panel without a PhD. What I didn't realize is I was going to be the only one in the room without a PhD. So I'm going to hang with Chancellor Sharp here in a little bit. We'll be together. So I'm really here to talk to you a little bit about International Space Station and what an amazing laboratory it is. So in a little bit, Julie Robinson will talk a little bit more about some of the research on ISS, so I'm going to focus on a couple elements. So today, on board the International Space Station, what enables it to do the things that it does is a regular supply of visiting vehicles. So having new experiments come up and bring cargo to the International Space Station and bring those down. This regular supply chain is really key in the success of all the things that are going on the International Space Station. Today, supply vehicles come up about every 6 weeks, and I'll talk a little bit more about that in a minute. You see on the other side of the crew of the chart here, our crew. Today we're celebrating our 17th and a half year of continuous human presence. 17 and a half years. So students who are seniors in high school this year have never known a time when humans weren't living and working in space. Just an amazing time. So you see our crew members right there. In June 14th of 2005, one of our astronauts, John Phillips, actually testified before Congress. And if you have to testify before Congress, actually doing it from space is a really good way, because if you want to stop, you just pull the plug. But anyway, John Phillips said, "We are the experiment." So he's talking about the crew. So not only do these folks conduct investigations. So today on board the International Space Station, these 6 folks are conducting over 329 different investigations, 85 of which have never been conducted before. Many of those investigations are actually involving them as test subjects. I think of, for today's purposes, I think of the work, the utilization of ISS in 3 categories. So research, commercialization, and technology development. Julie's going to talk about research here in just a minute, so I won't talk won't talk too much about that. I'll focus on commercialization and tech development, but really these things overlap. And so in some cases when we talk about commercialization efforts, some of the commercialization efforts are to support the research that could go on board ISS. Or some of the technology development efforts also help research, or some of the research development helps technology. So they're all interrelated. You saw this chart here, Ellen had showed it earlier about NASA's vision for expanding human presence in the solar system. We've been talking about this at NASA in these various phases, initially on ISS, going out in the lunar vicinity, and ultimately on to Mars. The reason I bring this up here is really for context. So today, for technology development, what we are doing is technology development for this entire vision, but we're really focusing on that first part. In fact, it's labeled as phase 0 on this chart. So the things that we're doing, we're actually testing equipment on board ISS today that needs to be tested in a space environment with a metabolic load in some cases. We're actually taking readings of the environment, all to drive the technologies that we need to be successful in putting humans for long duration in the vicinity of the moon, on the lunar surface, and ultimately onto Mars. One of the key technology areas, and Robert mentioned it in his discussion, is environmental control and life support. So we actually have extensive plans to test in this particular area. For instance, something as simple as carbon dioxide scrubbing, you'd think, well, that's something that we should have down pat. We've been doing it for years in space. We do it in submarines. We do it in other closed environments. And we can do it successfully on ISS. The things that are really difficult, though, are reliable, especially reliable in the context of a multi-year mission to Mars, lightweight and without a supply chain. So those are the things that we're really focusing on. And in fact, we have a number of technologies that we're testing, will be testing on ISS. And later this year, we actually have a number of racks that are going to go up to be focusing on this. It's not only carbon dioxide, it's actually closing the water loop. So today, we recycle about 80 to 85% of the water on board International Space Station. But really, to go to Martian-class missions, we need to be up in the upper 90%. So what are those technologies? How do they function in that environment? And can they be reliable and low mass? So we're testing on those right now. Another area of technology development is working with industry to test some of those things. So here in this picture, you see the Bigelow Expandable Activities module, or BEAM. This module was actually launched to ISS a year and a half ago. The interesting thing about expandable technologies, mass is not a huge mass savings, but you can see it can be launched in a much smaller volume and then expand to a much larger volume in space. That's what's a great thing, especially again for longer duration missions. Having adequate volume for equipment, supplies, and for our crew is really one of the key challenges for us going forward for long duration missions away from the planet. Other areas we've done some technology development. So OPAL's a laser communication experiment that was done on board International Space Station that was recently returned to Earth, and by returned to Earth I mean it was burned up. It came out externally. ROSA, or the rollout solar array, is a new technology for lightweight solar arrays, and that was tested on board the International Space Station this last year. So just examples of some of the technology demonstrations and development that's going on board ISS. Commercialization is a big thrust for us these days. So what is commercialization? That's a really good question, and we'll talk a little bit more of that at the end, but that's a thing for a really long debate. This picture here is a NanoRacks deployer. It's deploying CubeSats. Today, on board the International Space Station, we've deployed over 140 CubeSats. We're actually the largest deployer of CubeSats. It's really an important feature of our commercialization effort. As we speak here today, on board the International Space Station, there's an experiment to develop high quality optical fibers, Z-band fibers. Made in Space flew up an investigation on the SpaceX 13 vehicle that's up there right now, and in fact, it'll be landing, leaving the ISS and landing on Saturday. So we'll button it up tomorrow, and tomorrow evening we'll button it up, and it'll come home on Saturday. So this is an investigation that's going on right now, and we're really looking forward to seeing the results of that. This fiber is extremely expensive to manufacture on the planet, and it might be much cheaper and higher quality to manufacture in space. So we're looking forward to that. As I mentioned earlier on, having a regular supply chain, bringing up not only investigations and facilities, but also food and spares for the vehicle, for the ISS itself. Having these cargo vehicles is really important, but it's also a feature of our commercialization. So a number of years ago, we decided to sign contracts for a firm fixed-price contract to fly cargo, for a service, basically, to deliver cargo to the International Space Station. And today, SpaceX and Orbital ATK, SpaceX flies the Dragon, Orbital ATK flies the Cygnus vehicle, and very reliably brings cargo up to and away, and takes results back down and trash back down to the planet. In 2020, Sierra Nevada will be flying the Dream Chaser vehicle, and you see it here in this picture. So we're already working with Sierra Nevada. We're working with them as we speak, and looking forward to having the Dream Chaser vehicle to the fleet of vehicles that can bring cargo up and down from the International Space Station. Later this year, as Ellen mentioned, and I think there's going to be a talk here in a few minutes over lunch. You'll hear a little bit more about this. We'll talk about commercial crew. So we're working right now with SpaceX and Boeing to fly vehicles to the International Space Station, fly crew to the International Space Station. Really, really important. Today, all our crews launch from Kazakhstan aboard a Russian-designed Soyuz vehicle, and they land in the middle of Kazakhstan. As we said before, the crew is a lot of the experiment, but today, when the crew touches down in Kazakhstan, it's about 24 hours before they actually touch down here in Houston, where a lot of the research facilities are. So it's really a 24-hour lag from them touching the ground to actually taking a lot of the data, or even starting to take a lot of the data. So an improvement not only from a research perspective, but even more important, or certainly more important to me, on July 21st, 2011, 6.5 years ago, STS-135 landed in Florida. That was the last time that humans were launched and landed in the United States. And it's about time we start flying humans to the United States again. One of the things that commercial crew will also enable is something that's happened on board International Space Station before, but I think we'll see again, is actually having non-professional astronauts fly to the space station. So to date, we've had quite a few folks fly to the International Space Station, although none in about the last 9 years. So we've had Dennis Tito, Mark Shuttleworth, Greg Olson, Anusha Ansari, Charles Simeoni. Actually, Charles flew twice. Sheikh Muzaffar Sukar, who flew from Malaysia. Yisun Yu, Richard Garriott, Guy Laliberté, and Marcus Pontus all have flown up to the International Space Station, but done so on a Soyuz vehicle. I think commercial crew from the United States will open up additional opportunities for that. Finally, I said, what is commercialization? This is one of the things, if you talk about challenges, commercialization of low Earth orbit is a challenge. So it's certainly a challenge for NASA. Commercialization can be many, many things. So if you ask, in fact, if we took a poll in here about what is commercialization, what is commercial, we would probably have at least as many opinions as we have people. I have 2 or 3 myself, so I'm probably not alone in that. And that's what we're trying to do, foster a robust low Earth orbit economy. That's what ISS is challenged with right now. The one thing I know for sure is that NASA or the United States government or any government can't be the one to say what is commercial and what isn't. What is commercial and what's viable has to be driven by entrepreneurs, commercial companies, and obviously NASA and the government has to be a part of that. So that's what we're endeavoring to do on the International Space Station. In addition to technology development and research that Julie's going to talk about, we're really working with companies, with cases, to foster this low Earth orbit economy and let commercial companies and the market drive exactly what we should be doing on the International Space Station. So with that, I think I will look forward to any questions you have, and I'll hand it back to Ellen. Thank you very much.
So if you have a question, can you please step up to the mic? I see one right here in the middle.
No, I was curious about what does a CubeSat do?
What does a CubeSat do? So the CubeSats can do a lot of different things. One of the really interesting things is there's a company called Planet Space who actually tested a couple of their CubeSats off the International Space Station that were Earth observation CubeSats. And then they actually, I'll say, matured their design, tested it, made sure it was successful, and then went to a commercial launch provider and have launched a constellation of Earth observation CubeSats that you can go out today. And in fact, I think they've used those in disaster relief. They were actually used during Hurricane Harvey disaster relief. That's an example. Research, Texas A&M and the University of Texas actually launched a pair of satellites that actually were mated together initially and separated once they got into space. So it's you know, a huge, all kinds of things. There's a satellite actually that went up, a CubeSat, that was to test the biological effects of radiation. So they were actually going to do some investigations about what happens to some cells in a radiation environment that could be monitored remotely. So almost anything you can imagine nowadays can be done in a CubeSat.
Yes, please go ahead.
So regarding, I'm right here.
Okay.
Regarding being able to take people back and forth to this space station from the U.S., so are there current commercial ventures at least developing test flights? How close are we? When can this happen?
Yeah, that would be a great question. You're going to have Chris Ferguson and
It's
Gwen
coming?
Shotwell. I don't know if they're in the room right now. Those are the people you need to ask. But if you look at their current schedules, the schedules that they have provided to NASA right now, their first uncrewed test flight should be later this year.
Okay.
And actually should have a crewed test flight either the very end of this year or the beginning of next year. But Gwen and Chris can probably give you their dates.
I mean, it's not so far off. I was worried you might have told me 5 or 10 years. So.
No,
No,
it's happening soon. It'll
It
be
needs to
here.
happen soon.
It'll be here. Yeah. That's a different discussion. But yes, it's happening very, very soon, and I think it's a really exciting time. Work is going on those vehicles every day. There's parachute test happening this month. There's abort test that's going on. There's engine tests going on. These guys can tell you all about it. But really, an exciting time.
Thank you.
That's not to mention, by the way, there's other companies that are not part of ISS that are working on human. Blue Origin is looking at flying humans into space, maybe a slightly different model. And Virgin is also looking at flying humans into space.
Thank you, Kirk. We'll move on to our...
Oh, I'm sorry.
Was there another... I'm sorry. Please, go ahead. Bess.
NASA Goddard was interested in interplanetary use of a CubeSat. A DRO around the moon is a lunar stabilized orbit. Phobos and Mars has a stabilized orbit. It's much, much closer. And I worked with Goddard to try and put a CubeSat around there. Right? Pretty damn good mission. It was turned out. Why?
Okay, Robert, where's Robert Lightfoot when you need him? Actually, I can tell you for sure that you're talking about interplanetary CubeSats. So there was a, I'll call it a competition for a number of CubeSats to fly, or secondary payloads to fly on the first SLS mission. And in fact, I suspect it'll go beyond the first SLS mission. So on one of the adapter rings, there is the ability to eject secondary payloads, CubeSats. And so I think that absolutely we will be flying interplanetary, certainly beyond low Earth orbit CubeSats here in the very near future. We
Did I
won't
mi-
be deploying from ISS though. We're way too deep in the gravity well to do it from ISS.